These are some really important reactions that you guys need to know. So an alkali metal plus oxygen would give you, yes, a metal oxide. It oxidizes. The alkali metal oxidizes. Okay, so an example of this, lithium from group 1, yes, because obviously it's an alkali metal. Lithium plus oxygen. We have the symbolic equation as well. So Li, solid, plus O2, bivalent gas, oxygen, would give you lithium oxide, LiO2, solid. Okay, so that's easy enough for you guys to know. Just remember, alkali metal plus oxygen gives you metal oxide. So a very important test you guys need to know as well is when you're testing for hydrogen. So this is known as the Squeaky Pop Task. This is because if you hover a lit splint over a test tube containing hydrogen, there will be a squeaky pop as soon as you swipe it across, okay? Oh, halogen in water, so displacement reaction. Okay, so your halogen, chlorine, bivalent, all halogens are bivalent, Cl2, and it's in water, so AQ, aqueous. Plus sodium bromide, okay, would give you sodium chloride. This is your salt, and then you also get bromine. So as you can see here, the sodium was joined to bromine, but now chlorine has come into the mix and it's bumped bromine out, so it's displaced the bromine, meaning bromine is left all by itself, and then chlorine is more reactive and therefore it's happier with sodium. So chlorine bumps out hydrogen because it's more reactive than bromine. Bromine would bump out iodine because bromine is more reactive than iodine. Iodine would not bump anything out. Iodine, if it started on its own here, iodine, it would finish off by itself over here because it's just not as reactive as chlorine or bromine. You may ask, why aren't we using fluorine? Because it's the element that's above chlorine in the group, but fluorine is just way, way, way too reactive to be able to experiment with it safely. It's literally known as the T-Rex. It's so destructive. Okay, so here you have another reaction. So instead of chlorine, we've moved down to bromine. Oh look, potassium iodide. Again, in solution. All of this reaction is in solution. So, oh look, iodine is bumped out because bromine is more reactive than iodine, and bromine is then happy bonded to potassium as potassium bromide. Okay. Here I have a little table for you guys to know. So chlorine reacting with potassium chloride wouldn't do anything because you're reacting chlorine with chlorine technically. Bromine with potassium chloride, again, no reaction because chlorine is more reactive, so the chloride will stay attached to the potassium. Iodine, again, no reaction because it's even less reactive than bromine. Here, chlorine will displace the bromide ions because it's more reactive. So it'll be very happily bonded there. That's, oh, so you see sodium bromide here, but literally if it was just KBr, then you would have virtually the same equation, just you change obviously these letters. Here bromine would not react because it's reacting with itself, it'll just be happy whatever. Iodine isn't reactive enough to displace anything, okay? So chlorine reacting with potassium iodide, it would definitely displace the iodide ion, because it's way, way, way more reactive than it. Bromine would also displace this, as you can see here. Again, because it's more reactive. Iodine wouldn't displace because it's fighting against itself. So it's just happy to leave itself be. Okay.